In this video, we're going to do a few extra examples using implicit differentiation. So let's look at this first one. So I have negative 4 over 5x plus cos of 3y equals ln of 2y. So it's difficult to solve for y. So if I want to take the derivative, I'm going to have to do this implicitly. Now I might want to rewrite this before I start. So negative 4 over 5x can be written as negative 4 over 5 times 1 over x, which is x to the minus 1, plus cos of 3y equals ln of 2y. So then, when we take the derivative, so we're going to do the derivative with respect to x of both sides, which means that we actually want to do this to each term. Okay, so when I do the derivative, so maybe I'll just write that out. Actually, I won't. So I'm going to do the first term here. So this term has only x's, and I'm taking the derivative with respect to x, so this is a normal derivative. So I'm going to have negative 4 over 5 times negative x to the negative 2. So I brought down the power, the negative 1, and then I subtracted it by 1. Okay, now I want to add. So here, when I take the derivative of cos of 3y, there's a y, and I'm actually taking the derivative with respect to x. So I need to remember here to multiply by y prime, or dy dx. So the derivative of cos is negative sine, okay, and then the inside stays the same. Now using the chain rule, I want to multiply by the derivative of the inside, so that's going to be a 3y prime, or dy dx. So that's my derivative there. And then when I take the derivative again here, it's of y, and I'm taking with respect to x, so I need to remember to multiply by y prime. So when I take the derivative of a ln, it's 1 over the thing times the derivative of the thing. Okay, so I'm going to get 1 over 2y times 2y prime. Notice that these 2's are going to cancel out. So now I want to get the y's by themselves. So what I'm going to do is add this term to the other side. Okay, so then it's gone on this side. So I'm going to have over here 4 over 5x squared equals, and now I can factor out the y prime here. So it's going to be 1 over y plus 3 sine of 3y. Okay, so then if I solve for y prime, it's going to be 4 over 5x squared divided by 1 over y plus 3 sine of 3y. So that's the derivative. Now there's fractions within fractions. So this 5x squared can just go to the bottom. So I'm going to have 4 over 5x squared times 1 over y plus 3 sine of 3y. And then if you want to get rid of that 1 over y, we can just multiply by y over y. And it's going to be 4y over 5x squared times 1 plus 3y sine of 3y. Make this a bit smaller. There we go. And then I can fit it all in. So this would be our derivative here. Okay, let's try another one. So here, for the first part, so I'm going to do the derivative of each bit here. For this part, I'm going to have to use the quotient rule or the product rule. Okay, I'm going to use the quotient rule. So it's going to be the derivative of the top. So that's just a 2 times the bottom. Okay, I did not differentiate a y. Okay, so it's just this. Now I'm minus. Now I have to take the derivative of y cubed. So that's going to be 3y squared. Here I'm going to need the y prime. And then times by the top, which is 2x. And then it's all over the bottom squared. Again, no derivative down there, so no y prime. Now when I take the derivative of 5y, the outer derivative is 5, and then it's going to be y prime. The derivative of x is just 1, and the derivative of 7 is 0. Okay, so now I want to simplify. So what I'm going to do is I have two things that are subtracting on the top over the same bottom. So I can actually write this as two different fractions. I want to do that because y prime is in one of them but not the other. So this is going to be 2y cubed over y to the 6 minus 3y squared. Oh, actually I can simplify this. Okay, so minus 6xy squared times y prime over y to the 6 minus 5y prime plus 1 equals 0. Okay, now what I'm going to do is move, well actually let's move the y prime terms to the other side because they're both negative and they're going to be positive now. And I can simplify this first term. It's going to be 2 over y cubed plus 1 is going to be equal to, I'm going to factor out the y prime. So this is going to be 6x over y to the 4 plus 5. So that means that my y prime is going to be 2y cubed plus 2 over y cubed plus 1 over 6x over y to the 4 plus 5. So again, we could simplify this. I think if I multiply by y to the 4 on the top and the bottom, that's going to be enough to get rid of all the fractions. So then it's going to be 2y plus y to the 4th over 6x plus y to the 4th. Okay, so this is going to be our derivative. So y prime or dy dx without having fractions within fractions. Okay, a couple more. So here we want the slope of the tangent line at the given point. Okay, so here's our point, -1, 1. Okay, so that means that we want dy dx or y prime when x is equal to -1 and y is equal to 1. So we want to take our derivative. Now again, it's hard to solve for y in this equation, so we can do our derivative implicitly. Okay, when we take the derivative of this term, we're going to need the product rule. Oops. Okay, so the derivative of x is 1 times square root of y, so I did not differentiate a y, plus the derivative of square root of y is going to be 1/2 y to the -1/2 times my y prime, or I'm going to use dy dx here just to be different, times the first function x. Okay, so that's our derivative. Okay, so this whole thing is the derivative of just this part here. So now I want the derivative of x squared. Okay, it's x, so it's a normal derivative, so it's just going to be 2x, minus the derivative of y, so that's going to be 1 times dy dx. Okay, and the derivative of -1 is 0. So I want my dy dx terms on the same side. So what I'm going to do is add dy dx to both sides so that it disappears, and then subtract root y on both sides so that it disappears over here. And that's going to give me x over 2 root y times dy dx plus dy dx equals 2x minus root y. So I can factor out dy dx now. So it's going to be x over 2 root y plus 1 equals 2x minus root y. So now I divide. So dy dx is going to be 2x minus root of y divided by x over 2 root y plus 1. And again, we can multiply by 2 root y over 2 root y just to make it look a bit nicer. And we're going to have to expand that through to both terms. So it's going to be 4x root y minus 2y over x plus 2 root y. Okay, so that's our derivative. And now, I didn't have enough space here. So now I want dy dx at x equals -1, y equals 1. Okay, so I want to plug in those values. So this is going to be 4 times -1 times root of 1 minus 2 times 1 all over -1 plus 2 root of 1. So that's -4 minus 2 is -6 over -1 plus 2 is 1. Okay, so I think that I get it that it's -6. So that's going to be our final answer. Maybe I'll just write that here. So the slope of our tangent line is -6 at the point -1, 1. Okay, let's try another one. This one is a bit more complicated. Okay, so again, I want the slope for the tangent line. So I'm going to take the derivative implicitly. So remember that this is 3 over 2x plus y squared to the power 1/2. Okay, so that's our equation. So when we take the derivative, I'm going to have to use the chain rule. So it's going to bring the 1/2 down, leave the inside alone, and it's going to be to the -1/2. And then I have to multiply by the derivative of the inside. So that's going to be 3 over 2 plus 2y times y prime. And that should be equal to 1. Okay, now, at this point, we're actually done differentiating. Okay, so we took all the derivatives that we need to take. Differentiating. So we could plug in our values now. So it's x equals 2, y equals 1. That's going to make our solving a bit easier. Okay, so as soon as you're done taking all the derivatives you need to take, you can plug in your values. Okay, so that's going to be 1 over 2 times 3 over 2 times 2 plus 1 squared to the power -1/2 times 3 over 2 plus 2 times 1, y prime is still there, equals 1. Okay, so what this is it's 1 over 2, this is 3 plus 1, so this is 4 to the -1/2, 3 over 2 plus 2y prime. Okay, so now 4 to the -1/2, this is actually 1/2. So this is actually 1 over 4, 3 over 2 plus 2y prime. So if I multiply by 4 on both sides, I get 3 over 2 plus 2y prime is equal to 4. So then I can subtract the 3 over 2. So 2y prime is 4 minus 3 over 2, which is 5 over 2. Right? It's 8 over 2 minus 3 over 2. And then I divide by 2. So I get y prime is 5 over 4. Okay, so that means the slope of the tangent line at the point 2, 1 is m equals 5 over 4. Oh, I did it again. There we go. So you could have solved for y prime like we did in the first one. We solved for y prime and then we plugged in our values. But you are allowed to plug in your values as soon as you're done differentiating, okay? You want to be careful not to do it before you differentiate, because then your derivatives should be 0, right? They're going to go to 0. But after you're done taking all the derivatives, then you can plug in your numbers, and it will make the solving part a bit easier.